Okay, so welcome to DEP1 feedback. This is the first time I've done this, so apologies if it doesn't go brilliantly. We're just going to start by telling you what you need to do, because obviously this is the first time you've done a DEP. So on your assessment that your teacher's given back to you, there will be a space for successes with some numbers and a space for targets with some numbers. The first thing that you need to do is to use your purple pen to write in the correct successes for you based on what numbers your teacher's written on your sheet, so that you've got that recorded. Okay, so what you might want to do is to pause this video now and note down what the successes are, okay, and then the targets as well for your assessment, how well you've done. Okay, so once you've filled those in, which will take you a certain amount of time, the next thing to do is to think about your response. Okay, so your teacher will have written some adjustments into the box that's on your marking sheet, and you need to respond to those adjustments. Okay, many of them will be maybe rewriting an exam answer if you didn't do particularly well at it. You might be asked to add something to it. You might be asked to respond to the annotations that your teacher's written on it. There's a range of things. The first thing to do is to, again, use your purple pen to correct all spelling and punctuation errors. If you've got Mrs. Carr, I will have put them in SP for spelling, P for punctuation. I'm not quite sure what Miss Barker does, but I'm sure you'll be able to work it out. So correct those spelling and punctuation errors. You should be correcting them with the correct spelling or the correct punctuation, for example, capital letter. Don't just guess, okay? Use a dictionary, use your folder dividers. Make sure that you correct those spellings and punctuation errors first of all. Okay. The next thing that you're going to do is to complete your adjustments that your teacher has set you, again using your purple pen, on the marking sheet in the box that says student response. So they may be numbered, so it would be useful for you to number your responses, a bit like answering a question, so that your teacher can see what you've done. Just bear in mind when you're doing this that this is the most useful part of the whole assessment process for you. So you need to spend an appropriate amount of time and do this properly in conjunction with watching this video using the mark scheme, okay, as well. My classes may have some A's on their work, particularly for the longer 9-mark answer. There will be things to respond to on your work, so what you might want to do is to number each of the A's, okay, and then number them in the response box and write your response in there. Sometimes they're just a short answer, so it might just say which type of wave or something like that, so you might just write that on your work, just a destructive wave or a constructive wave, something like that. Okay, don't forget to use the mark scheme. The mark schemes can be a bit daunting at first. We will help you with that this time. They are behind the marking sheet in that booklet to help you complete your responses. Okay, so we'll start to go through the question by question with some advice about sort of what you did well and what you didn't do quite so well. So this question, just to be sort of truthful about it, this is a question that you wouldn't get on your current A-level paper, because this is an old specification question. However, so the command word is not quite right. However, you could get something very similar to this. A 4-mark question at A-level would be explain. So the question could be explain the links between the different parts of the coastal system. You may get given a source like figure 5, but you may also not. The biggest problem from my perspective with this question was that some people just described what the diagram in figure 5 showed without using any of their own knowledge. You're obviously not going to get very much credit for that in the exam. In fact, you get no credit for it. So what the examiner's looking for here is links between each section of the diagram. So for example, if you can link fetch with wind strength, so if you could say that a longer fetch means that the wind has been blowing over a greater area of the ocean for a longer period of time, that would increase the wind strength. That would lead to wave type, and you need to specify what wave type. A long fetch would lead to strong wind, would lead to destructive waves. Then that would lead to particular types of wave action. Okay, so in this case, if we're talking about destructive wave action, you could talk about a weak swash and a strong backwash that would lead to erosional processes such as abrasion. Okay. On the other hand, if there was a weak wind strength because of a short fetch, the wave type would be constructive, leading to a stronger swash and a weaker backwash, and leading to deposition. So you'd need to actually show your knowledge of how wind links to fetch, links to wave type, leads to action, leads to processes. The mark scheme is here now on your screen, and it's talking about the same sort of things that I've talked about, the fetch, the resulting wave type. Okay, I'll see whether I can write on the board. It might make it more difficult for you to hear me. Okay, so it's talking about the strength of the wind, okay, the distance over which they've travelled, the fetch, okay, obviously the direction links to the angle at which the waves hit the beach, okay, the resulting wave type depending on what the strength of the wind and the fetch was will have an effect on the wave action, as I said. So whether the swash is dominant or the backwash, determining the range of attack. Okay. What a lot of you missed, so the better answers talked about wave refraction, which we'll talk about in a minute. So wave refraction is mentioned on this diagram, and very few of you mentioned it. You kind of tried to avoid it, I think. So it is a higher level of understanding, but you need to try and get your head around that if you're going to do well at A level. So just to remind you about wave refraction, so this is to do with headlands and bays. Okay, so obviously we're talking about discordant coasts. Okay, so discordant, I don't know why the pen is changing colour, discordant coasts, okay, where you've got alternating soft rock where the beaches or the bays are, and hard rock where the headland is, and those rocks are in layers or I suppose, they are lined up perpendicular or at right angles to the sea. Because of that, the waves, as they approach the headland, start to bend. Okay, they approach the headland, the water's shallower, and friction with the seabed starts to slow them down, but it also causes them to bend, and that's what refraction is, wave refraction. And what some of you wrote about really well was they converge, but make sure you get it the right way around. So the waves converge or come together at the headland, creating high energy and erosion, but diverge in the bays, creating low energy and deposition. And if you start to talk about that, then you're going to get far more marks in the exam. The second question was the multi-choice question. In my classes, everybody got that right. The correct answer was B, so I'm not going to say anything about that one. The next question was also not an A-level question, it's an AS question, is this one. So again, you would not get the command word describe in an A-level paper, okay? But for these purposes, you know, it was good to see how much you knew about the characteristics of the waves. What you should have recognised was that you were told that it was a constructive wave. Okay, so make sure you read all parts of the question so you know what it is you're talking about. The characteristics that you were looking for, you needed to actually use the picture. So you should have been talking about, well, let me draw on it. You should have been talking about the waves spilling onto the beach. They're not plunging like a destructive wave, they're spilling onto the beach. Fairly low wave height, so you've got a gentleman in the sea over here, well, let me draw on it. who kind of provide some scale. So, you know, a low wave height, they're not particularly tall, and a big distance between the waves. Okay, so a long wavelength, you could describe it as, or low wave frequency. And for a constructive wave, that would be 6 to 8 waves per minute. You need to be learning these facts that relate to the topic that we're talking about. What you might have noticed, and one or two people did, is that the wave that's in the background that's breaking beyond this guy that's in the sea is actually steeper and a bit more plunging. So towards the shore, they're more constructive, but breaking further out, they look a little bit more like destructive waves. Only 2 marks available for that. And you wanted some of those kind of characteristics describing what constructive waves are like. Question 3A part 2 was where you talk about what the effects are. Okay, so things like the fact that the swash would be stronger than the backwash. This would encourage the beach to be built up, with sediment being deposited or deposition being greater than erosion at this on this particular beach. Some of you talked about the features, the depositional landforms that might be created, like beaches, bars, spits, things like that, which was really good. Okay, so actually this question was pretty well done, as long as you'd learnt your wave characteristics. So the mark scheme, I don't want to spend too long on this because it isn't an A-level question, but you can see the sort of things that you would get your marks for. A bit difficult, this last point on the second part about the beach, because we hadn't done that. But, you know, we gave you credit for saying, you know, depositional landforms, which many of you knew from GCSE anyway. The next question was probably a little bit less well done. Again, it's an AS question. You wouldn't have outline, but you could have explain the role of wind in affecting coastal energy. For this one, show you the mark scheme, you need to be talking about how waves are formed. And that's in this very first part of the mark scheme here. So wind is responsible for the generation of waves as friction occurs on the surface of the water. And not many people in my 2 groups got that. Okay? The rest of this mark scheme is very similar to the first question about what happens when there's stronger winds. So it's about getting that relationship perhaps between fetch, wind speed or wind velocity, the wave types, whether that's destructive or constructive, and then the processes of erosion. The processes of erosion with destructive waves and transportation and deposition with constructive waves. The other thing that a lot of people missed was the importance of wind in longshore drift, okay, which is here in the mark scheme, but my pen doesn't want to pick it up. Okay, so it's here. That longshore drift obviously determines the angle of the swash when the waves hit the coastline, and that then determines the direction of the longshore drift. Okay, lovely. The last question, you have got the mark scheme in your on the back of your mark sheet. It's quite lengthy. The first bit of it tells you what the level descriptors are. So this question, a 9-mark question, is marked out of 3 levels, so level 1, 2 or 3. Okay, so it tells you what they are. All right, and then it goes on to give you the A01. Okay, it's not going to let me write on it. Okay, so the A01, no, it doesn't want to let me. A01, remember, is right over here. No, A01 is knowledge and understanding. Okay, so your knowledge of the different sources of energy on the coast, and then your understanding of the impact of those sources of energy on the coastal environments. And then the AO2 is where you answer the question basically, where you actually talk about, is wind the biggest factor or is it something else? Okay, so our top teacher tip for this was to make sure that you talked about all of the different sources of energy. So a good place to start would be with wind. Okay, so again, as I've talked to you about a few times already this, in this video, you want to be talking about fetch. So fetch leads to the greater the fetch, the greater the distance that the wind has travelled across, can create more energy in waves and give you destructive waves. What the best answers did was they said, okay, wind's really important, but actually it's wind that creates the waves. Okay, so that would be your 802 point, that the wind is essential for creating the waves, and really it's the waves that produce the energy on the coast, that affect the type of processes, whether that's erosion and transportation with destructive waves, or whether that's deposition with constructive waves. So fetch and wind was really important. Okay. Some of you avoided, I think, talking about tides, or possibly ran out of time. Okay, so we need to get to the bottom of tides. Tides have nothing to do with wind. So if you like, it's a counter-argument. If you're trying to argue that wind does have the biggest factor in coastal energy, tides are the complete opposite. They are something that is not affected by the wind. It's affected, as most of you will know, by the sun and the moon, okay, and so on, okay, and the gravitational pull. So, just to recap on tides, because there's definitely a little bit of confusion, a spring tide, so the one that's at the bottom here on this diagram, is where the sun, the moon and the earth are all aligned or in a line. Okay, so aligned is a good word to use, so they're all aligned. What that does is the sun and the moon both create a gravitational pull. If they're all in a line, there's a greater gravitational pull on the earth, and the gravitational pull is what causes the tides. Okay, so in a spring tide, greater gravitational pull means more extreme tides, a higher high tide and a lower low tide. So on this diagram, you can see that there's a larger tidal range. Now, what you needed to talk about in this question, you'd get some marks for just explaining all that stuff about spring tide. You get some 801 marks, but the AO2 marks, all right, are where you apply your knowledge of spring tides to the question. So we're talking about coastal energy. If you've got a large tidal range, as you have where there's a spring tide, the area that the sea is going to erode, and it won't let me draw on it really annoyingly, okay, the area between these two dashed lines, it won't let me draw on it at all, very annoying, is much greater because the tidal range is greater. So you've got a much greater aerial extent, okay, so a greater area, a greater aerial extent, oh my God, a greater aerial extent of erosion. So the erosion, the power, the energy is over a larger area, okay, so there's erosion over a larger area, but obviously because it's over a larger area, it's going to be less strong, because the waves are only going to be crashing against part of the beach for a relatively short space of time before the tide starts to go out again. In a neap tide, the moon and sun are at right angles to each other, and so therefore create less gravitational pull because the gravitational pull is working against one another. So you get a lower high tide and a higher low tide, less extreme tides, a much smaller tidal range. So the area between the two red dashes on here is much smaller. So you get a smaller area that's eroded, but the power of the waves is more concentrated. But remember, that has nothing at all to do with wind. Okay, so that's going to help you to answer the question. Okay, storm surges are to do with wind. Okay, so they're also to do with low pressure or depressions. Okay, but they do create lots of wind, which will also create some energy on the coast. So you could bring in storm surges. As a counter argument, so if we're saying that wind is the biggest factor, that's what we're trying to argue, wind is the biggest factor in determining the coastal energy. In actual fact, you might want to argue that it isn't the biggest factor in determining the impact of energy, because geology is actually more significant. So you might take the example of Cornwall in the southwest of the UK, where the fetch is 3,000 kilometres plus. Huge fetch, okay, destructive waves, but less erosion because the geology is granite and limestone, which is quite resistant to erosion, as compared to the North Sea and the Holderness coast, where the fetch from the northeast is about 600 kilometres, but so much less power in the waves, but the geology of boulder clay means that that's the fastest eroding coastline in Europe. So you might want to bring that in as a counter argument against wind. I've already talked about refraction, but you could talk about refraction here. Refraction, again, has got nothing to do with wind. It's only to do with waves and what happens to the waves as they approach a discordant coast, as they approach those headlands. So again, it's a counter argument against waves. All right. In terms of, we've talked about tides. In terms of currents, okay, longshore drift obviously is very much determined by wind direction, the prevailing wind, as we've already talked about, the angle of swash coming up the beach. So even though you might argue that currents like longshore drift are very important as a large-scale transportation process on the coast, they are still determined by wind. Okay, so my advice for you in this final question is try and talk about all four types of energy. So learn those four types. All right, wind, waves, tides and currents. Try and build in some counter arguments against wind. So for example, geology, wave refraction, tides, which are not caused by wind, and you must write a conclusion. So you must write a short conclusion that goes back to the question. And in actual fact, the best answers write in paragraphs. So you might write a paragraph about each of the four types of energy, and at the end of your paragraph, you go back in a sentence to the question and use that paragraph that you've written to answer the question. Okay, so if you're writing about tides, tides are, they are saying that, they're not the most, wind is not the most important factor on the coast because tides are not caused by the wind. Your judgment, it doesn't matter what your judgment is, it doesn't matter whether you say that wind is the biggest factor or it isn't the biggest factor, as long as you justify yourself. And with the tides argument, a lot of my students wrote that actually these tides don't happen that often. Twice, you get a spring tide twice in a lunar month, a neap tide twice in a lunar month. It's not that frequent, whereas the wind blows pretty much all the time. Okay, so it doesn't matter what your judgment is. What's important is that you've justified it and backed it up with some evidence. And that is the end of your DEP feedback. So what you need to do now is to have a look at what your teacher has asked you to do and do it.